Yes, after definition of partial differentiation, in order to make it more clear, so we are going to discuss very simple sums on partial differentiation. If y is equal to sin xy plus x square y plus x cube y cube is a function. I am denoting it by f because y came out on the right hand side. F is this function. F is a function of x and y. Then find del f by del x. Okay, this is del f by del x. You may call it as daba also, daba f by daba y. I'll call del f by del y. Now, the derivative of f with respect to y I am going to take. This partial derivative of f with respect to y means what? It is the ordinary derivative of function with respect to y, but keeping x constant. While taking derivative of f with respect to y, I have to keep x constant. I have to give x constant. Now, derivative of sin xy with respect to y, keeping x constant, is cos of xy. Cos of xy. Derivative of sin is cos, and derivative of argument again. Derivative of xy is partial derivative of xy with respect to argument xy. We are taking partial derivative with respect to y. Therefore, we have to keep x constant. The x is constant, and derivative of y with respect to y is 1. The derivative of xy, I have to write 1 here. I am writing directly because this thing you have done 12th standard. Derivatives. Partial derivative was not there, but it is simply the derivative. But here in partial differentiation, we are keeping other variable constant. Okay, this is the difference between ordinary and partial derivative. Now, derivative of x square into y. X is constant. This function is constant, and derivative of y is 1. Here, x cube is multiplicative constant, and derivative of y cube is 3y square. This is partial derivative of given function with respect to y. What we have done here, we kept x constant. While taking derivative with respect to y, we kept x constant. That is what the partial derivative of f with respect to y. Now, partial derivative of f with respect to x. What I have to do? I have to differentiate with respect to function with respect to x, keeping y constant. The derivative of sin is cos xy, I have written here. Derivative of xy with respect to x, keeping y constant. Derivative of xy, keeping y constant. Y is constant, multiplicative constant, and derivative of x with respect to x is 1 into y. Means derivative of sin xy is cos xy into y. Plus, take derivative with respect to x again, keeping y constant. Y is multiplicative constant, and derivative of x square is 2x with respect to x. Derivative of x cube is 3x square. And y cube is multiplicative constant. I have to keep like that. Is it? So in this way, the partial derivative of f we found with respect to x and with respect to y. Now in our further sums, the difficulty level will be more. There's one more simple sum on find the partial derivative find the partial derivative of a function f, and the function f is x square minus y square plus 2xy plus tan of xy square in this way. The elementary knowledge of the derivative means you must have command on derivative and trigonometric formula here. So I am taking derivative with respect to, find partial derivative of this with respect to x. So how do you get partial derivative of the function with respect to x? I have to keep y constant. When you take partial derivative with respect to x, keep y constant. See, derivative of x square with respect to x is 2x. Now here, derivative of y square, this is the constant term. Derivative of constant is 0 with respect to x. See, here we have the multiplication of two elements x and y. The 2 is multiplicative constant. Y is multiplicative constant because we are taking derivative with respect to x. X is variable, y is constant. And derivative of x is 1. Derivative of tan function is what? Sec square. Sec square of this argument. And in the multiplication, derivative of xy square. Derivative of xy square with respect to x, because we are taking derivative with respect to x. The x derivative of x is 1, y square is constant, means y square is the partial derivative of xy square with respect to x. So here I have to put y square in this way. These are very simple sums where we have found derivative with respect to x, y. Okay, we may come across the double derivative also. Now, here the difficulty level is comparatively more. If u is equal to sine inverse of x by y plus tan inverse of y by x, then find x del u by del x plus y del u by del y. We are going to find out the value of this component where del u by del x is required and del u by del y is required. What I am going to do, I am going to find derivative of u with respect to x, because del u by del x is required, del u by del y is required. So these two derivatives are required, therefore I am finding values of these two derivatives separately, then I will put it here and then I will get the value. Here u is equal to sine inverse of x by y plus tan inverse of y by x. Is it? You don't now differentiate with respect to x partially, or you can write here keeping y constant. Differentiate this u with respect to x keeping y constant, or differentiate u with respect to x partially, you can write. And derivative of u, partial derivative of u with respect to x is what? But while taking derivative, you don't forget to keep y as a constant, because we are taking derivative with respect to x. Now derivative of sine inverse of x by y. What is derivative of sine inverse? I am writing formula for ordinary derivative. What is derivative of sine inverse of capital X? Is what? 1 by under root of a square minus x square. Derivative of sine inverse of capital X is what? 1 by under root of a square minus x square. And derivative of this argument again we have to write derivative of capital X with respect to small x. But instead of capital X, small x is there. Then d small x by d small x will be 1. No need to write it. And one more formula will be required. Derivative of tan inverse of capital X. This is what? 1 by a square plus x square, and multiplied by derivative of capital X with respect to small x again in the multiplication. Okay, just you are aware of these two formulae. Now derivative with respect to u, I am writing derivative with respect to x keeping y constant. Now derivative of sine inverse of this function means what? 1 by under root 1 minus argument square, okay, multiplied by derivative of x by y, derivative of x by y with respect to x. Here I am writing derivative of x by y with respect to x is what? Derivative of x is 1 and 1 by y is constant, means 1 by y. Derivative of x by y, it will be also required. Derivative of y by x is what? Derivative of y by x. Here y is constant and derivative of 1 by x is minus 1 by x square. Y is constant. Okay. Now, once again, u is the given function. Differentiate with respect to x keeping y constant. The derivative of sine inverse is 1 by under root 1 minus argument square multiplied by derivative of xy with respect to x, which is 1 by y, plus derivative of tan inverse of the argument is what? 1 by 1 plus 1 by 1 plus this argument square. Is it? Here derivative of it is x by a. Here I am writing 1. Here I am writing 1 square is x by a. Okay, in this way. So the derivative of x by a, the only x is there. So 1 square is 1 and 1 square is 1, like that. Now, the derivative of tan inverse y by x I have written. This multiplied by derivative of y by x in the multiplication I have to write with respect to x, which is minus y by x square. Okay, this step is important. You have to write it very carefully. Now, once you take derivative, del u by del x we have written, and for the sake of simplicity, I am going to increase one more step. Here y square is LCM. And this y square will jump in the numerator from under root. If y square is there in the under root, it will, when it is coming out of the root, it will be y only. So I am directly writing y by under root y square minus x square. Okay, into 1 by 1. What I have done? I have taken LCM y square. Under root of y square is y, and it will jump in the numerator in this way. Plus, here also I am taking x square LCM, the x square plus y square. This x square will jump in the numerator, minus y by x square, as it is. Okay. Now this y and this y gets cancelled. This x square and this x square gets cancelled. This is equal to 1 by under root y square minus x square minus y by under root y by x square plus y square. Now similarly, del u by del y, differentiate the given u, differentiate 1 with respect to y partially. Y partially means what? Differentiate with respect to y, keeping x constant. Is it? here we have differentiated with respect to x keeping y constant. Now here we are differentiating with respect to y keeping x constant. Now derivative of u with respect to y I am writing in this way, del u by del y. Derivative of sine inverse is 1 by under root 1 minus x by y whole square. Because this argument itself is a variable now, because we are differentiating with respect to y is variable and x is constant. But this argument is made up of x and y, therefore we have to treat this as a variable. Now, derivative of x by y with respect to y is what? Derivative of x by y with respect to y, x is constant, and derivative of 1 by y is minus 1 by y square multiplied by. Okay, what is this? This is derivative of x by y plus derivative of tan inverse is what? 1 by 1 plus argument square multiplied by derivative of y by x with respect to y, keeping x constant. Derivative of y is 1 with respect to y, and 1 by x is as it is, means 1 by x. And again, do the same thing. Just you take LCM, then y square will be there in the numerator. Next step, del u by del y is equal to del u by del y is equal to. I am going to make the partition this way. This y square is LCM, writing directly y square minus x square. In the denominator of this, y square will be there, it will come out as y and it will jump in the numerator in this way. Minus x by y square as it is. Here x square is LCM, then x square plus y square. This divided by x square, here I am writing directly, and 1 by x is there in the multiplication. Now if there is some cancellation you can perform, this 1 y gets cancelled, minus x by y is already there, 1 y gets cancelled, under root of y square minus x square, plus 1 x will get cancelled, x by x square plus y square. Isn't it? This is del u by del y, this is del u by del x. Now what we have to find here, we have to find out the value of this component. Now I am going to consider this component. What? X del u by del x plus y del u by del y. X del u by del x plus y del u by del y. Is it? Now putting value of those components, see, del u by del x value I am here putting, plus y, del u by del y value, so I am going to put. What is value of del u by del x? Del u by del x is 1 by under root y square minus x square minus y by under root y by x square plus y square. Okay, this is the value of del u by del x which we have found here. Now value of del u by del y, this is the value of del u by del y which I am going to put now. X by y under root y square minus x square plus x by x square plus y square. Isn't it? Now multiply these two elements by x and these two elements by y. What will you get? X divided by under root y square minus x square minus xy divided by x square plus y square. What we have done here? X into this term, x into this term, simply. Now similarly here, x minus x into y is x, y with negative sign. And this y gets cancelled, this will be multiplied by y. The y will get cancelled. And here, x square is being cancelled, y gets cancelled like that. Okay. minus x, one y gets cancelled. The y square by x square under root, this y is going to cancel now after the multiplication, plus x into y, this is divided by x square plus y square. This we have the all multiplications. X multiplied by these two terms, y multiplied by these two terms. While multiplication, this y gets cancelled, therefore y is not, y is disappeared. Now, if you look at it very carefully, if there are some cancellation, xy by x square plus y square negative sign, xy by x square plus y square positive sign, minus x by under root y square minus x square, and the same thing here with plus, that these two are going to cancel, these two are going to cancel, they are equal with the opposite sign, the value of this is 0. Means the value of x del u by del x plus y del u by del y is 0. Okay. So this type of problems you have to have the practice on it. Only the elementary knowledge of the derivative is required. Now prove that. Second sum of this. If prove that del 2u y by del t square is equal to a square del 2y by del x square. Okay. Del 2y by del t square equal to del 2y by del x square for y is equal to function of x plus at plus function of x minus a. We have to prove this now. Okay, if you look at it very carefully, we have double derivative of y with respect to x and t. Double derivative of y with respect to x and t. So the double derivative of y with respect to x and t, how do you resolve? Del 2y by del t square means what? Derivative of y with respect to t 2 times. See in this way. Derivative, first of all you have to take derivative of y with respect to t. Again derivative of y with respect to derivative of the resulting thing with respect to t in this way. Similarly for del 2y by del x square. Now y is given. Y is given to you. The y is equal to f of x plus a. It is a function of f. F stands for any function. Instead of f, there may be sine, cos, square function, root function, whatever. So y is equal to function of x plus at plus function of x minus at. Okay. Now, I want double derivative of y with respect to t, double derivative of y with respect to x. So differentiate with respect to t. Keeping x constant. Keeping x constant. See, here the variables are what? T and x. Okay, because these are independent variables. In derivative term, the t occurs in the denominator. So these are independent variables, and there are two variables we have to deal with. That is x and t. Just from derivative term you come to know what are the independent variables. Here t and x are two variables. So we are differentiating with respect to t, keeping x constant. Okay. Now, del y by del t, taking derivative with respect to t, keeping x constant. So the derivative of f, I am denoting it by f dash. F dash is the derivative of f. And derivative of x plus at in the multiplication I have tried. Derivative of x plus at with respect to t. The derivative of x with respect to t is 0 because we are keeping x constant. A is multiplicative constant and derivative of t with respect to t is 1. Means derivative of x plus at with respect to t is a. This is multiplied by a. Now, derivative of function g is g dash I am writing. g dash of this function, and derivative of x minus at with respect to t is minus a. Derivative of x minus at with respect to t is minus a because derivative of x is 0 and a is multiplicative constant, derivative of t is 1, minus sign is as it is. So this way. Now again differentiate with respect to t, keeping x constant because we want double derivative. We want double derivative. Del y by del t we have obtained. Now again take derivative with respect to t so as to get double derivative of y with respect to t. The double derivative of y with respect to t is equal to, see, derivative of f dash, function f dash is f double dash. Okay, a is multiplicative constant, this I have to write as it is, a is multiplicative constant, and derivative of x plus at with respect to t is a plus, now derivative of g dash I am taking, minus a is multiplicative constant, derivative of g dash is g double dash, x minus at. Okay, this you may call this as a prime or dash. Okay, this will depend on you. Derivative of x minus at with respect to t is minus a. In this way, double derivative of y with respect to t we have obtained. Now try to simplify it. A multiplied by a is a square, which is constant. This as it is, minus plus a square, and this is as it is. So in this way, the double derivative of y we found. Now, double derivative of y with respect to x here to find. Double derivative of y with respect to t we found. Now double derivative of y with respect to x you try to find. Now then we want del 2y by del x square. What are we going to do? The same thing we have to do. Differentiate on this with respect to x, keeping t constant. Keeping t constant. Is it? Now derivative of y with respect to x, del y by del x, derivative of f is f dash, x plus at, and derivative of x plus at with respect to x, keeping t constant. T is constant, a is constant, means a into t is constant, derivative of constant is 0 and derivative of x is 1. Into 1 is the derivative of x plus at plus derivative of g is g dash, x minus at, and derivative of x minus at similarly like this is 1 again. Now del y by del x we obtained. Now again differentiate with respect to x, keeping t constant. Keeping t constant. Okay, you can write differentiate with respect to x partially or differentiate with respect to x keeping t constant, but it's the same. Now derivative of y with respect, derivative of del y by del x with respect to x is this thing. Okay. Here 1 is there in the multiplication. We have a single function, derivative of f is f double dash. F dash is f double dash. Okay. And derivative of x plus at again is the multiplication I have to write, which is 1. Derivative of this with respect to x is g double dash or g double prime. And derivative of x minus at with respect to x is 1 again. So in this way, these two derivatives we have found, that is double derivative with respect to y and double derivative with respect to x. Okay, we have to prove this thing. Okay, this we are going to do. Means here two derivatives are required. The values of the derivative first I have calculated. Now check whether these two are same or not. Okay, this is now considering 2. 2 implies del 2y by del t square is equal to, here on the right hand side a square is common, that's why I am taking a square common. F double dash x plus at g double dash x minus at as it is, because a square I have taken common. But here now f double dash x plus at and g double dash x minus at is del 2y by del y square, del 2y by del x square. The left hand side is as it is. Okay, and hence we have proved. Okay, hence it is true. Once again I am going to repeat in short. Here y is given to you, double derivative of y with respect to t, double derivative of y with respect to y I have calculated, and if you look at it, look at this equation 2, a square is common, I have taken a square is common, and rest of the thing is del 2y by del x square, which is double derivative of y with respect to x. That's all. In this way we have proved.